Hello, everybody. Today I give a talk about some work we've been doing in Yosemite National Park for almost 20 years now, maybe a little over 20 years. It's an exciting place. It's a place I love to go, and I encourage you, if you want to see this place, it's actually quite easy to see just from the Mono Meadows trailhead. So, ecosystem impacts of managed wildfire in Yosemite National Park. So, outline for today. First thing is the policy changed in Yosemite in 1972 to allow burning. Many of us don't remember this very well, but National Park Service suppressed all fires just like the Forest Service did for almost 100 years. So they kept fire out of their systems too, just like everybody else. And then the Leopold et al. Report happened in 1968, implementation of that report from a previous publication in 63. And parks like Yosemite began to change. And in 1972, they changed their policy to allow for both prescribed burning and managed lightning ignitions in the backcountry. So, of course, these fires are carefully monitored. Today, they still are as well. There's this idea of let burn. The let burn thing is basically not really talked about at all because it almost feels like you're just letting fires do what they want. And that's not the case at all. They're monitored every single day, and decisions are made on them on a daily basis. Suppress, allow to burn, whatever you want to do. Today, about 85% of the park is in actual fire use areas. One place in particular has been really interesting, Illilouette Creek Basin. And Jan van Wankendonk has been working here for a number of years and one of our collaborators. So Illilouette Creek is just to the south of Half Dome. If you see Half Dome and you look to the south of that, that essentially is a lot of the Illilouette Creek Basin. It's part of the Upper Merced River watershed. So the questions for today, what are the burning patterns inside this area? How this impacted vegetation, the burning that's happened in Illilouette Creek? How about hydrology? Is there some evidence of changing hydrology in this basin from the 45 years of fire use? And what about climate change? Is there any evidence or modeling that can actually help us understand what climate change might do to this system? Well, here's a picture of Yosemite, of course, and you can see the outline of Yosemite National Park. And down here to the center bottom of the park is the Illilouette Creek Basin. That's outlined there in that little dashed line. So you can see it's just to the edge of Yosemite Valley, which is this little area here. And it's relatively large. You know, you're talking about 15,000 hectare watershed. And pictures to the right are actually after some recent fires, lightning ignited fires in the basin over the last 20 years or so. And you can see in the bottom picture, a lot of grass, meadow created. We're going to talk about that. And the upper picture, we see some scorched Jeffrey pine trees. So trees that have had some fire damage just from the most recent fire. This picture shows kind of the jigsaw puzzle of the different fires that have burned here. And this is something we're going to explore in just a moment. But you can see there's a tremendous number of fires in this site. Again, these are all lightning ignited fires. And this has happened all since 1972 with the largest fire that began the whole program, the 1974 Star King fire. That was the first one that really burned with any size. But since then, there's been many, many fires in this site, and those different colors on that picture show you the different fires that have burned over the decades. Here's a picture of one of the more recent fires, the 2001 Hoover fire. And you can see that this is an area of kind of upper mixed conifer forest. We see a lot of granite and red fir, Jeffrey pine, white fir, lodgepole pine. Those are the species that dominate here. Also quaking aspen, certainly shrubs, willow and others. So this is a place that's upper elevation mixed conifer. It's above the true mixed conifer forest that some folks talk about, including me, sugar pine, Jeffrey pine, incense cedar, ponderosa. This is higher up. One thing that's interesting about this place, though, it's right in that transition zone and it actually gets more snow than rain. So this is a watershed that's snow dominated. Certainly it gets some rain, but we're in the snow zone. So here's a picture of the Hoover fire. It's one of the larger fires that burned in the last 20 years. And it actually had some high severity patches in it. What about fire history? So again, here's the Illilouette Creek with our fire perimeter data on top of it. And Brandon Collins did a fire history out here with tree rings. So he went out there and collected tree ring samples and then did the cross dating. And if you look at kind of the pre-suppression era, 1700 to 1900 or so, we had a mean fire return of about 6.3 years, about 6 years or so. From 1972 to 2006, the period that the sample covered, Brandon also took fire history samples from this site, and he got a mean fire return interval of 6.8 years. So the paper actually shows, this Collins and Stevens paper, that the fire regime is relatively restored and not dissimilar from what it was pre-suppression. In some ways, that's quite interesting. 100 years, no fire in there, fire comes back, and then the intervals are relatively the same. And this is interesting because, you know, that's a long time to keep fire out. And there actually has been regeneration in this site because of that regeneration getting established in fire-free period. We actually have documented really a cohort of trees growing in that time. But still, even after that long exclusion, the fire metrics are relatively similar. This map kind of shows areas that have reburned more than once or one time. And what you find is, as you go higher and higher elevation, you can see over here to the right or to the east and also to the south, this gets really high elevation. It goes to rock. So a lot of those areas have no vegetation at all. Of course, they're not going to burn because they're just too high. But other areas down here in kind of the core of the Illilouette and also the lower elevation, a lot of those places have burned 2-3 times since 1972, with a few small areas burning up to 5 times. So you're seeing essentially a place that's had fire almost wall to wall. In fact, when we go into this site to try to do research, sometimes we want controls, you know, areas that haven't burned for comparison. We've pretty much convinced ourselves that the controls in this landscape that haven't burned is because of a reason. One reason might be because there's a large rock outcrop in front of it, or maybe it's isolated because of topography. So I don't think there actually is any controls left in the Illilouette Creek Basin. Things that actually have a chance to burn are burning. And it's really hard to find an unburned area. It's kind of cool. Well, let's take a look at a little data. And this is one of the pieces that Brandon Collins has worked on and published. So here we see essentially the perimeters of fires. Each of those polygons, different color or different fire. And you can see we have numbers in between. What this is showing us is as a fire hits another one, this one with 1 year return interval, here we see 2 fires intersecting with the previous fire happening 7 years. What we see essentially, these fires are self-limiting. A little enclave here didn't reburn because it burned 5 years previously. So those are limited fires. So these are fires simply being limited by fuel because of just the character of the system. So they're really becoming self-limiting. On the right now, you'll see some places we basically have longer periods, 30 years, 23 years, and we see a fire perimeter here going on top of that mosaic. And you see here the mosaic is basically getting burned over. So as time goes on, fuels increase, of course, and then the ability of this site to reburn happens. So not surprising we get these reburn fires. So if you do a statistical analysis on this, what we find is a really interesting pattern. Let's look on the right here. This is the one that's really interesting. So when Brandon did a categorical tree analysis, he found out from all the fires in the Illilouette Creek that when the reburn interval was 9 years or less, when a fire basically hits another area, but it had burned 9 years or less, that in no cases did that fire reburn the area. And in 10 cases, it was limited. Now what happens when you have a reburn interval over 9 years? So then the burning index comes into play. The burning index is basically a proxy for a fire weather. It's used in the National Fire Danger Rating System in the United States. So if the burning index is relatively low, around 35, we find out that there's 4 fires that reburn and 4 fires that are limited. However, if the burning index is above 35, we see that all of the fires reburn. Yeah, so we see a fire weather piece here. So we see a split on the reburn versus non as fire weather gets more extreme. But the thing that's most interesting is the 9 years, about 10 years or so. So what this is telling us essentially is if the if the fire regime continues and you're encountering fires that actually are reburning at 9 years or less, then in 95% of the cases, these things are all being self-limited. One thing about this diagram that's really interesting is it's 9 years. It doesn't mean that you have 3 fires in 50 years or maybe 4 fires in 60 years. It literally is telling you what you've done for me lately, because it's saying you got to keep this fire regime going, because it's not how many fires have occurred in the last 30, it's how much years for the last one. That's kind of powerful in terms of just what that's telling us. It's telling us that the fire regime has to continue to see these benefits. Here's a picture of fire severity classes. And the severity of the Illilouette Creek from 74 to 2004 has been stable. And we know from Jay Miller's work, Hugh Safford and others, that the severity patterns of many mixed conifer forests in the Sierra Nevada are increasing. So we're seeing higher proportions of severity and also larger patches of high severity fire. Illilouette Creek does not show this at all. We're seeing essentially stationary. We're not seeing changes in severity at all. Very interesting. What about vegetation change? Here, really interesting study. Gabrielle did a study looking at, over the left is the Illilouette Creek remote sense photographs, 1970. You see the gray is rock, the green is forest. And after the fire regime is reintroduced to 2012, we see that the forest area has been reduced by 22%. Wet meadows increased by 200, dry meadows 200, shrubs by 30. So you're taking really a forest that was basically fire suppressed for 100 years, wall-to-wall trees, and you've converted it to a mosaic of vegetation. And this isn't just, thinning forest. We're talking about a forest previously classified 1970 is now completely a different vegetation type. Forest to shrub, forest to grass. So this is a real change. And you go in there today, it's remarkable to walk around and to see the mosaic of vegetation. And that picture shows us how much the return fire regime has sculpted that system. Pollinators have actually increased in moderate severity areas. So there's a really interesting pollinator study that could be talked about. I won't have time to talk about that much here, but what about the water? Let's go to the water. This is a telling slide. So Gabrielle did another study showing here with these purple watersheds are outside of Yosemite. They're in similar elevation, similar vegetation, similar geology, but they have very little fire at all. Versus down here is Illilouette with the blue perimeter. What she found is when you look at a hydrological analysis based on stream gauges, and luckily there is a stream gauge on the Merced River at Happy Isle, we find that the amount of water leaving Illilouette Creek per unit water in, either snow or rain, has remained stable or slightly increased since 1974. And all of the other areas around Yosemite that have had no fire, every one of those has had a significant decrease in the amount of water leaving. So Illilouette Creek is either stable or slightly increased depending on the weather data you use, and the other areas are all decreased during the same time period in their runoff coefficient. That's pretty big. We know water is huge in California. The most recent fire was the Empire Fire, 2017. There you see area of the Empire did burn in Illilouette Creek. It was actually the latter part of the Empire Fire, but it eventually reached it. And that's been interesting as well. So now we've been doing hydrology studies out there. It turned out it burned through our 3 areas where we've been doing intensive hydrology measurements. Then this is the last slide I wanted to talk about is what about climate change? So here, Katia has been doing some work with climate change and has a paper almost completely accepted in the Journal of Hydrology, just a minor revision needed. And she's done some modeling of the Illilouette Creek in a climate change scenario as we go into the next 40 years or so. And the question was, do we see the benefits of maybe slight increases in hydrology outcomes, such as more soil water, slightly more stream water? Is there evidence in a modeling framework that this might continue? And the answer is yes. The one thing it does show, though, is actually if you start kind of beginning again, like in 72, that the transition to the different vegetation types I showed you in the previous, where we lost around 22% of forest cover, happens faster. So it'll happen faster because of climate change and warming, but the mechanics and the hydrology continue to show that we'll see a benefit of increased soil moisture, which actually led to less mortality during the drought, the 2012 to 2016 drought in the Sierra Nevada. We measured less mortality of trees in the Illilouette. We actually measured higher soil moisture during that period as well. And the modeling shows that it looks like there's some evidence that these systems can still regulate, continue, at least for the next 40, 50 years, and still see some of those hydrological benefits. So last slide here. Frequent fire forests have greatly changed in California. A lot of you know that. You've heard that from multiple people. Climate change makes it worse, but it's not the biggest factor. My view is it's really the forest structure, the conditions of these systems that are really the essential piece. And climate change is another stressor that's adding to that system. California water scarce, and we're experiencing higher numbers of severe wildfires. And despite warming, managed wildfires in the Illilouette Creek are promoting a healthy watershed. Illilouette Creek is one of the closest places you're ever going to go to in California that actually has a functional fire regime, and it's working today. That's why I invite you, if you want to, go into the Mono Meadows Trailhead, take a hike to Illilouette Creek. You're in Illilouette Creek probably in less than an hour. And if you want to go further, backpack in there, spend some time. I always find it to be just gorgeous, incredible. Increased stream flow and wildfires persist even with warming climate. That's good. And then the question then becomes, in my mind, is what about bond funding or ways that we can get more work done in some of these watersheds to increase water, stabilize water resources? Of course, water is hugely important in this state. I think that bond funding is one way you can do it, but I'd also like to see the California water agencies invest in these systems. The water agencies don't invest in any of the headwaters that I know of in this state. I find that a little appalling. So I think it's maybe time for our California water agencies to also benefit watersheds through management and activities. Next 1 to 2 decades is critical. I'm still optimistic, but I'm also worried. We're seeing fires in scale that are happening, severity patterns outside anything we want. So the next 1 to 2 decades is critical. I think we have to move decisively through restoration, mechanical methods in some places, restoration of fire regimes. If we don't do that, we're just going to see the forest change right in front of our eyes. And with that, I'll acknowledge a few folks, people that I've worked with over the years. It's been fantastic. Jan van Wegendonk should be on that slide, but he's not. Jan is a good friend and colleague and incredibly important. Thank you.